Yes, Ritesh Kumar Maiti, are you there?
Yes, sir.
Okay, so we will wait for 4 to 5 minutes, then we will start our session for electrical machine. Okay, so I am taking the classes of electrical machine, which will having the code of EE 301. Okay, so another faculty member from our department, he will take the another portion of the machines. Okay, so we will try to complete the syllabus so that we will take the classes according to the two faculties is concerned. Okay, so
Okay, sir.
okay, so I am doing the module 4 and the module 5, and the module 1, 2, 3. The Anil Kumar sir will be taken. Okay, so let them other student will join, then we will start our session. Okay, Ritesh.
Okay, sir.
Okay, fine. Yes, Ritesh, let your friends to be join. Okay, because some of the student will may not be known. Okay, today we will take the classes. Okay, so whatever your connection you have,
Yes, sir. But
you
maximum student are joining. Sir, maximum student are joining Telegram, but they didn't know that the class is going
no,
on in
from our
Google Meet.
department, I am sharing. We are sharing some Google link, na, according to the routine is concerned. Okay, so that Google Meet link. Okay, the same link we are doing.
Okay, sir.
Okay, so communicate with your friends among your circle. Okay, today I am taking the classes. Okay, so that they will able to join in this particular link. Okay.
But sir, we here but Telegram.
Okay, fine. So
Link is not.
I will communicate accordingly.
Yes.
Okay. 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 Yeah, very good morning, student. Am I audible to everyone?
Yes, sir. Yes, sir.
Yes, very good morning. Uh, Today we will discuss about the electrical machine, right? So I am taking the classes of electrical machine, right? So which you have already been taught in your lateral entry courses, right? So we have a total five or six module we have in our syllabus in our Jharkhand University of Technology syllabus. So I am taking the module 4 and the module 5, and the rest of the module that will take by the another faculty, Mr. Anil Kumar sir. Okay, so that we are taking the two faculty members according to the syllabus is concerned. So we have to complete the syllabus within 14th of March. Okay, so we have a very limited period of time, so that we are concerned about the syllabus competition, because during this particular period you have an internal examinations also for the first internal examination. Okay, so we will try to complete more syllabus, at least 70 to 75% syllabus. It will not able to complete the total syllabus during the short span of the time. Okay, so we will try to complete more and more syllabus, so that it will able to understand what the syllabus is, what will be the syllabus, and what will be the pattern of the question paper, okay, which will be published by the Jharkhand University of Technology in their university's examination, right? So, how many are there? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, fine. So, Ritesh Kumar Maiti, are you there?
Hello. Yes, sir.
Yes. So, can you prompt me as a present set like this? So, I have give your attendance for the today's session, right? So, I am looking for Ritesh. Ritesh,
Present, sir.
Amar Kumar,
Present, sir.
Akash Garai.
Present, sir.
Okay. Samrid Raj, something, I think.
Present, sir.
Okay. Om Radha Kumari.
Present, sir.
Okay. Karan Hasda.
Present, sir.
Okay. Ashish Kumar Paswan.
Present, sir.
Deepak Kumar.
Present, sir.
Sweta Kumari.
Present, sir.
Vikram Kumar Mato.
Present, sir.
Okay. Amitesh Bhatt.
Present, sir.
Sonu Yadav.
Present, sir.
Nilesh Kumar. Nilesh Mahato. Sorry.
Present, sir.
Okay. Abhishek Avi.
Present, sir.
What is your title, Abhishek?
Sir Abhishek Kumar Yadav, sir.
Abhishek Kumar Yadav. Okay, fine, fine. So we have a do you have a syllabus with you? Whatever the syllabus you have in electrical machine.
Yes, sir.
Okay, so uh, I'm sharing the syllabus so that you will able to see what able to understand what is actually there in the syllabus in the module 4 section. The module 4 section will be comprised with a, DC machine, right? The construction principle of the DC machine, overview of the DC machines, some principle of operation, what are the different types of DC machine that will available, what will be the power circle diagram, power flow diagram, speed control, armature reactions, okay, different kind of constructions of a different kind of machines. So these are the things that will available in your syllabus for electrical machine. Okay, so in that case I'm sharing the screen so that you will able to see what the syllabus is actually. Yes, yes, syllabus is visible to you.
Yes, sir. Yes, sir.
Okay, fine. So here if we will see that, sorry. Here if we will see that there must have a total one, two, three, four, five modules is there. Okay, so first three module will be taken care by Mr. Anil Kumar sir. Okay, first three module, that means the review of the magnetic circuit and the electromechanical energy conversion. The second module, that will be comprised with a single phase transformer and the auto transformer. Module 3, that will comprise a three phase transformer, and module 4. So module 4 and the module 5, that means the DC machines and the DC machines monitoring and the generations. Okay, so that thing we are I am taking. Okay, so today we are looking about some basic constructional principle of the DC machines, how the DC machine will be work according to which principle, what will be the magnetic structures of a stator and the rotor segment, okay, of a DC machine. So, that thing we will discuss today. Okay, so in that case, this is actually your syllabus for the module 4 and the module 5. In the module 4, you have seen that there's some basic construction of the DC machine, magnetic structure, what will be the stator yoke, stator poles, pole face, pole shoes, air gaps, armature core, some visualization of the magnetic field which will be produced by the field winding excitation and the armature winding open. What will be the air gap flux density distribution, flux per pole, induced EMF in the armature coil. So a lot more things is there in this particular DC machine. So we will communicate accordingly whatever the points that will be pointed out in this particular syllabus. Okay, and we will go through this very quickly so that we will able to complete the module 4 and the module 5 within 7 to 8 classes, right? Okay, so and if you have any question during this particular session, please ask me. If you have any problem regarding whatever you supposed to be, whatever I have taught, you have not been understand, it is not been understandable, then kindly prompt me. Okay, so that I'm able to do in another way. Okay, okay. So okay, okay. So I'm stop the sharing. I am sharing the another screen. Yes. Now my screen is visible to you.
Yes, sir.
Okay, fine. Okay, fine. So, today we are emphasizing on the some overview of a direct current machines. Okay, so what are the contents that is there in this particular topic? Okay, so what are the contents that will be discussed in this section? So contents are, one second, size to be modified. Okay, so what are the content we must be comprised? So contains, we have, first we have a content of a overview of a direct current machines. That's overview of a direct current machine. So M slash C, that means direct current machines. So then we will discuss about the construction. Okay, then we have a discussion on the constructional principle. Okay, then we have a discussion of the principle of principle of operation of a DC machines. So number 4, we have a discussions of a type of DC machines. What are the different types of DC machines that will available in the market? Okay, so that thing we will discuss. Number 5, we have a discussions on the power flow diagram. Okay, so we have a small discussions of a powerful diagram, and how we have a speed control of a DC machine. Okay, So speed control of a DC machine. So these are the things we have to discuss in this particular section. So these are the things. So overview of a direct current machines, constructions, principle of operation. So in the principle of operation, we have a discussions of some types of coils. Okay, so what are the different types of coils? Okay, so we have a discussions of a armature reactions. Okay, so these are the things we have discussions in the DC machine. So these are the main thing which we will discuss in the DC machine part. Okay, so according to the syllabus is concerned, or according to the chapter or the module is concerned, so from this particular module you can able to understand what will be the principle by which the machine will be convert the mechanical energy to the electrical energy. We have a discussion on the operational difference between the different type of, that means operational principle of a different kind of generator. Okay, so in this particular section we have a discussion, we have an understanding of a principle of a DC generator, as it's represent a logical behavior of a DC motor, right? So these are the things we have. This is actually the learning objective in this particular module, right? So what are the learning objective for this particular module? Because the DC machines is a preliminary things in a machine module, right? So we have to understand what will be the learning objective, right? One second, I have a call. Hello, 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 हेलो, हाँ बोलो, हाँ बोलो। ফরম্যাট তো আমার কাছে আছে, আমি কিন্তু ক্লাস নিচ্ছি, আমি নিয়ে তাহলে পাঠাচ্ছি তোমাকে। হ্যাঁ ঠিক আছে, ঠিক আছে, ঠিক আছে, ঠিক আছে, ঠিক আছে। ওকে, okay, so sorry for the interruption. uh, so my voice is audible now, students?
Yes.
Okay.
Yes, sir.
Okay, okay, fine. So these are the things we had to discuss. Okay, and now we have some overview of it. As you are the lateral entry students, you already read out the what the machine chapter, what the DC machines is. Okay, so some overview principle, some operating principle you already know, because you have been already been taught in the lateral entry classes. Okay, so I have a one questions that so direct current machines are divided into the two different part. What are the two different part? Can anyone told? Can anyone
Sir,
told?
stationary part and rotatory part.
No, 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 no. Station, not the stationary. So because the machines is always having a rotational movement. Okay, so that is the difference between the machine and the transformers. The transformer is called the static device, and the machine is called the rotating device. Why the transformer is called the static device? The transformer has no movable part inside the constructional principle is concerned, right? So that is why the transformer is called the static, although we can say that the transformer is machines also. Okay, but transformer having don't have any such kind of rotating part inside their construction. Okay, so that it will be considered as a static devices. Okay, but in such kind of machines have a two segments, one is a rotor and the stator, right? So the stator having a fixed component, and the rotor which will be moving, okay, movable component of a machines. Okay, so the machine have a rotational motion, so that is why we cannot say the machine is a static device. It's called the, also we call, it's called the dynamic devices, we can also be called. Okay, so in this particular chapter, the direct current machine is divided into the two different segments. I'm asking these things. Okay, so what are the two different segments? We have a discussions on the DC machine. That thing I'm asking. Anyone?
Sir, motor and generator.
Motor and
Generator.
yes, very good. Motor and the generator. That means the direct current machines are divided into the DC machines, direct current machine. So that is divided into the two different segment, right? One is my DC generator. Another one is my DC motor, right? So what are the difference between these two? Can anyone tell?
Sir, DC generator is a device which converts mechanical energy into electrical energy, and
Yes.
motor is vice versa.
Motor is vice versa. Okay. So, according to the principle of operation is concerned in the DC machine, so we are dividing according to the constructional observation is concerned. We are dividing the DC machine into the two different segments. Okay. One is called the DC generator, another one is called the DC motor. Okay, so you can told that most of the DC machines are similar to the AC machines also, because in your fifth semester you have another machine that will be called as a machine 2. Okay, where we have a discussions of a AC machines. Okay, so we can say that this DC machines, most of the DC machines are similar constructional principle of a AC machines, although they have a AC voltage and the current within them. In the AC machines must have a AC voltages, AC voltages and the AC current, right? AC current that will be involved. But in case of a DC machines, the we have a it will be called as a direct current machines, right? So whatever the voltage and the current we are concerning in the DC machines, that will be concerned about the DC voltage and the DC current. Although there must have a DC voltage and the DC current, so most of the DC machines constructional principle will be same as similar to the AC machines. Although they have in the AC machines they have an AC voltage and the AC current within them. Okay, so DC machines have the DC output just because they have a mechanism that will converting the AC voltage to the DC voltage at their terminals, right? So that particular mechanism is also called as a commutator. Are you heard about the commutator?
Yes, sir.
Commutator. So that particular mechanism, okay, that mechanism will be considered as a commutator. Okay, it should be considered as a commutator, right? So what will be the actual thing of the commutator is, so when the DC machines have the DC output, just because they have a mechanism that will converting the AC voltage to the DC voltage at their terminal, that particular mechanism is actually called as a commutator. So thereby this particular DC machines is also called the commutating machines. Okay, so this particular DC machine is also called a commutating machines. It's also called a commutating machines. Okay, so we can say that the DC generator are not as common as they have used to be, because the direct current which will be where it is required is mainly produced by the electronics rectifier, right? So we have a working principle of a DC generator. So in case what will be the applications area of the DC motors, so while the DC motor having a wide applications area such as an automobile, okay, so aircraft maintenance and some portable electronics devices, some speed control applications, okay, because our electrical engineering is based on the control system, right? So whatever the device we have to be controlled. Okay, so suppose we have considering the robot, so the robot has to be controlled using the mechanism of a mechanical science. Okay, so while we are considering the applications area of a DC motor and the DC generator, they must have a wide range of applications in our today's market or in our today's world. Okay, so that particular applications area that will be divided into the different segments. One is supposed to be the automobile, supposed to be the car manufacturing unit. Okay, so some aircraft maintenance unit, so some portable electronics devices which will be comprised with the DC motor. Okay, and some speed control applications. So everywhere in the electrical engineering we have a speed control applications. Okay, so speed control of a DC motor, speed control of an alternator, speed control of a induction motor, Okay, so there must have to control the speed of the operation of a DC motor or the AC motor, or the stepper motor, anything. So we have to control the speed. Okay, so we have to know the proper control system that will be behind the operating principle of a DC machines, right? So there must have a different applications area whenever we have to control any such kind of machines, right? So that is actually what the direct current machines observation is, direct current machine principle of observation is. So in that cases, we have divided the DC machines according to the construction is concerned. We have been divided into the two segments. One is the DC generator, another one is the DC motor. Okay, so what we can say in case of a DC generator, so DC generator is actually a machine that will converts the mechanical energy into the electrical energy. Am I correct? Am I correct? The DC generator will be did what? So DC generator is a machine. So DC generator is actually a machine that converts the mechanical energy. I am writing this ME, that's mechanical energy, to the into a electrical energy. So which will convert the mechanical energy to the electrical energy. That means a DC voltage and the DC current. Okay, by using the principle of so what will be the conversion principle? The principle is the principle of a magnetic inductions. Okay, so in which principle it will be working? The principle of magnetic the principle of magnetic inductions. So are you heard about the magnetic induction?
Yes, sir.
So what is it, magnetic induction?
The parallel of electromagnetic induction.
Yes, tell me.
So whenever a conductor is placed in a varying magnetic field or changing magnetic field, an EMF is induced within the conductor.
Okay, fine. So suppose that means we have putting the two electromagnets or the permanent magnets, and in between this we have generating some magnetic field. Okay, and that magnetic field will be compromising with the loop and the slip ring. So that thing will be comprised with the principle of a magnetic induction. So keep remind these things always. The DC generator, that the working principle that will be depends upon the magnetic inductions, right? So for an example, the end of the wire loop, because we have a different segment of the loops inside our coils. Okay, so the end of the wire loop has to be connected with the two slip ring mounted shaft, and while the brushes are used to carry the current from the loop to the outside of the circuit, right? So that thing, that working principle that will be applicable for the a DC generator. Okay, so main working principle that will be depends upon in the DC generator is the magnetic induction. I will discuss briefly what the magnetic inductions is in the latter part when we have the discussions of the principle of operation. One second. Hello. Huh? हाँ मनी. हाँ बोलो. हाँ, you send me the application to my mail and also the admin office mail. Okay, so I will forwarding the mail, then you will proceed the thing. Okay. Okay. So DC generator, and in case of a DC motor, what will be in which principle the DC motor that will working? Can anyone told? Can anyone told? Yes. Am I audible? Yes, Abhishek, are you there?
Yes, sir, you are audible.
Okay, so can you tell me the in which working principle the DC motor is working?
So the principle is that when a conductor carrying a current is placed in a magnetic field, it experiences a force.
It's experiences of a force. Okay, so a DC motor
Sir,
is
it's a
uh,
Fleming left hand rule, sir.
it's a Fleming left hand rule. Okay, okay, fine. So that thing you will already know in the basic electrical engineering when you have taught in the in your lateral entry when you are doing the first semester or the second semester, I think probably. Okay, so the same thing we are applicable in this particular third semester also, what the DC motor working principle is. So in that cases, the DC motor are everywhere. Okay, I am saying that the DC motor are everywhere. So whenever you have to collecting any devices, that will be compromising with the DC motors. Okay, so almost every mechanical movement, okay, that you can see around you is caused by the DC motor, right? So the DC motor is a machines which will converts the electrical energy into the mechanical energy by supplying a DC power. Is it or not? Is it or
Yes,
not? The
yes,
DC motor is actually a machine which will converts the electrical energy, which will converts the electrical energy into a mechanical energy, just opposite to the principle of DC generator. Okay, so DC motor is a device, or we can say that the machine which will converts the electrical energy to the mechanical energy by supplying a DC power, by supplying a DC power. DC power means power is compromising with the voltage and the current. Okay, power will be compromised with the voltage and current, right? So DC motor will be working like this. Okay, so what will be the advantage of a using of DC motor? The advantage of the DC motor is that it will be very easy to control the speed. Okay, so that means in every machine we have a control actions, right? So if we were using the DC motor, now there must have some advantages. So what the advantages is, if we using the DC motor in any such kind of devices, okay, so that will easy to control their speed in a wide applications area rather than we are using the DC generator, right? So there must have an applications area of this particular DC machines is huge, as I am already told previously, that there must have a different applications area either in the aircraft maintenance, either in the in some electronics devices, either in the automobile engineering or any such kind of speech control applications area. So there must have a different applications area we have been divided for the DC generator and the DC motor, right? So this is actually the basic overview of what the DC machines is, and according to the construction is concerned, what will be the different segment. We have divided the DC machines into the two different segment. One is the DC generator and another one is my DC motor. Okay, now we have a discussions on the construction according what will be the classifications of the electrical machine as the constructional features is concerned, right? So what are the different machine we have been observed in the market? Okay, so the classifications of the electrical machines, right? So there must have a classification, the classifications of electrical machine, classifications of electrical machine by their constructional features, by their constructional features. Okay, so what are these actually? Constructional, according to the constructional features is concerned, we have to classify our electrical machine, that means our DC machines, into the different segments. Okay, so the electrical machine that could be classified by the by the constructional features and their subdivision into the power output range. What will be the different range of the electrical machines, and what will be the different speed range. That means we are classified our electrical machines according to the constructional principle, according to the what will be the power output range, and according to the speed, what will be the speed of a particular machines. So these are the three classifications pattern we have to classify our electrical machines. Is it understandable or not? Yes, is it understandable?
yes,
बिकॉज द mainly the classify हम लोग कैसे करेंगे इलेक्ट्रिकल मशीन को थ्री डिफरेंट सेगमेंट में क्लासीफाई करेंगे. ओके, अकॉर्डिंग टू द थ्री डिफरेंट सेगमेंट, अकॉर्डिंग फर्स्ट वन इज माई what the construction of the principle is, what the construction of the motor is, or what the construction of the machines is. Okay, that means the constructional features. That means the constructional features. Okay, then we have to decide, we have to classify according to the power output range. Okay, according to the power output range, we have to classify our electrical machines, right? And the third one is what will be the speed range. Okay, that means what will be my speed range, okay, of a particular electrical machines. So according to this, we have to classify our electrical machines. Okay, so what are the classifications area of an electrical machines? So number one, okay, so supposed to be a small size electrical machines, we can say is small size electrical, a small size electrical machine, right? A small size electrical machines as per their power output. Okay, so the small size electrical machines with an output OP, that means it's an output, right? So it's an output up to zero point 0.6 kilowatt, right? So there will be the first classifications of electrical machine. That means we are choosing the small size electrical machines with a output up to zero point 0.6 kilowatt, right? Number two is we have a medium size electrical machines with an power output that will range from the zero point 0.6 kilowatt to 250 megawatt. That will be the medium size electrical machines. Okay, so we can say that it's a medium size electrical machines with a power output up to which zero point 0.6 kilowatt to 250 kilowatt. So this will be considered as a medium size electrical machines. So depending upon the different power output, we have a classified our electrical machines. So we have to concern about the power output range, right? And according to the constructional features also, supposed to be the small size, supposed to be the medium size. So depending upon the constructional features and as well as the power range, we have to divide it. The small size electrical machines having the power output up to 6 kilowatt, so that will be considered as my range of power output. For the medium size electrical machines, the machines with the power output between zero point 0.6 kilowatt to 250 kilowatt, which will be treated as a medium size electrical machines. Number three, large size electrical machines. Okay, we are considering the where large size electrical machine. If you visit to any such kind of power plant, we will normally see this kind of machines. Okay, so the large size electrical machines, according to the constructional features is concerned, we are choosing the large size electrical machines with a power output will be how much? That will be exceeded the 250 kilowatt but not beyond above the 500 kilowatt. So we are choosing the large size electrical machines which will exceed, that means which will be greater than the 250 kilowatt, but it will be not more than, or it will be less than or less than equal to 5000 kilowatt. So that particular, if the power output will be this, so that particular machines will be treated as a large size electrical machines. So the applications area of the large size electrical machines which will be considered in a power plant, where we will see the large size of electrical machines which will be considered for the generation of a power. Okay, so for the large size electrical machines, what will be the power range? The power range should be not exceed between, that means it will be from the 250, when it greater than 250, either it should be the 350 kilowatt or it should be the 500 kilowatt. So if the machine having a rating of having a specifications of a 500 kilowatt, suppose in every machines you will see some specifications is there. Okay, so if we will see that there must have a output range that will be 500 kilowatt. Okay, 500 kilowatt, so that machine will be treated as my large size electrical machines according to the power output is concerned. Okay, so this particular large size of electrical machines which are having the power output, it will be greater than 250 kilowatt but not exceeded the 500 kilowatt. So that particular power range, that will be compromising with the large size electrical machines. Okay, number 4, now we are choosing the speed range. Okay, so according to the speed range is concerned, the electrical machine as per the operation of a speed range, that has to be classified into the three different segments. So what are the three different segments? The low speed machines, medium speed machines, and the high speed machines. Okay, so first we have considering the low speed machine. So what are the load space machines is? Okay, so that particular machines, according to the construction will be concerned, or according to the speed range is concerned, we have to choose the speed range from. So in this particular machine, the speed range, the speed range that will be from 250 to 400 RPM.
RPM.
Right, 250 to 400 RPM. That means RPM is treated as a revolution per minute. Am I right? Am I right?
Yes.
Yes. So
Yes.
if this particular range that will be concerned, if that particular range will be concerned, then we can say this will be the low speed machines. Okay. Number 5 is the my medium speed machines. Right. So medium speed. So what will be the range of the speed? The speed range that will be speed range from 400. Okay, from 400 to 1500 rpm. If we are concerning this particular range, then this type of machine will be considered as a medium speed machines according to the speed range is concerned, right? So now next, the last one is a high speed machines. Okay, so this particular high speed machines is applicable for the generations of the electricity, right? So this high speed machines is normally used in a power plant. Okay, so what will be the speed range? What will be the speed range? So speed range that will be vary for the high speed machines is more than or greater than equal to 1500 rpm. So if any such kind of machine has to be specified more than 1500 rpm, so that type of machines will be called as a high speed machines. Supposed to be any such kind of machines having a 3000 rpm. Okay, so such kind of machine supposed to be the induction machine. Okay, so induction machine that will be operated in a 3000 rpm. So that particular machines will be treated as a high speed machines, which will be having the speed range of more than 1500 rpm. Right, so these are the different classifications of a different electrical machines that will be available in our market and available for the productions of a electricity. Okay, according to the constructional features is concerned, according to the power output range is concerned, and according to the speed range is concerned. Okay, so these are the three components where we have to classify our electrical machines. Okay, according to the size, according to their power output range, and according to their speed range. Okay, so I think 1 second, 1 second. Okay, so due to power cut, there must have a disconnection from the Google Meet. Okay, so we are connecting with the college server. So due to the power cut, the college server will be shut down. So I am doing my own. Okay, so am I audible? Okay,
Yes, sir.
okay, fine. So I'm sharing the screen again. Yes. Now screen is visible.
Yes, sir.
Okay, fine. So, so according to the constructional principle is concerned, okay. So, what will be the now we have to concern about the what will be the essential part of a DC machines, right? So then we have to start with the what will be the operational principle of operation, okay. So, what will be the essential part? Okay, can anyone told essential part of DC machine? Can anyone told? Yes.
Sir, field system, armature, conductor, brushes,
Field system, armature,
conductor and brushes. Poles.
conductor,
Commutator. Commutator, sir.
commutator. Okay,
Poles.
commutator,
Armature.
brushes. Shaft
The
is
pole.
there. Shaft is there or not?
Sir.
Shaft is there or not?
Shaft.
Shaft, shaft, bearings. These are the things which will be there in the DC machine. So what are the? There will be the n number of parts. We have a discussions. We have an yoke. We have a we have some field windings. We have a pole core. We have a pole shoe. Okay, so we have a commutator. We have an armature core. We have a yoke or frame. Okay, so these are the n number of things that will be there in the DC machine. But some of the essential part that will be there in the DC machines is the field system, in how in which principle the DC machines is working. Okay, so the first essential part we are concerning about the field system, right? So field system, right? Number two, we are compromising with the armature, which is a very important part. Okay, so from there we have to considering the armature reactions, okay, armature winding. Okay, so number three is my what, tell me?
Commutator.
Is a commutator, right? So commu commutator. Okay, so number four is my brushes. Okay, number four is my brushes. Number five, we are concerned about the bearings. Okay, balls and bearings, balls and bearings. Okay, number six, we are concerning about the shaft. Okay, so these are the six major part or the component that will be available in the DC machines. Apart from this essential part of the DC machines, we are having a core, we are having a yoke, we are having a pole core, pole shoes, field windings, liftings eyes, frame, armature core. So these are the things, so some of the parts that will be considered. So that is actually the main essential part of any such kind of DC machine system, right? So in the point number six, it will be treated as a shaft. Okay, so can anyone told ki what are this part is actually done in the DC machine, the shaft? Yes, can anyone told?
It is a rotatory part, sir.
It is a
Rotation, rotatory part.
it's a
Sir,
rotate.
it's hold the armature.
It's a hold the armature. Okay, so actually the shaft is actually a rotating part, such as an armature core. Okay, some commutator, cooling fans. Okay, so that will be keyed with the shaft. Okay, so shaft is actually nothing but which will be the very important part also. Okay, so shaft is actually the rotating part of any such kind of machines, like a like an armature core, a rotating part of a commutator, some cooling fans. Okay, that will arrange for the cooling purpose of a DC machines, right? So these are the two different part that will be available in the shaft segment. So whenever we have a discussions on the constructional principle of operation in the DC machines, then we will discuss the all the things very briefly. That means what will be the field system, what will be the function of the armature. So in the armature section, we have a different segment, supposed to be the armature winding and the field winding, right? In the commutator segment, we have and also some constructional operations is there. So brushes, balls and bearings, like this. Okay, so each and every components and each and every parts having some applications area. Okay, and what will be their working. Okay, what will be the what is it actually done by this particular part. Okay, so if I choose the point number 4, the brushes, so what will be the function of the brushes? Can anyone told? Can anyone told?
Sir, brushes collect the armature current, sir.
Huh. So brushes will be collect the current from the armature or for the commutator.
Yes, sir.
Okay, actually the brushes is actually collect the current from the commutator. Okay, and which will supply this particular current to the external load circuit. Okay, so external load circuit means any such kind of armature of a machines being connected to the external load circuit via the commutator and the brushes. Is it now?
Yes, sir.
Okay, so what will be the function? Is sometimes that particular question that will be asking by the interviewer also. Okay, so what are the different parts of a DC machines? Can you describe what will be the function of the brushes? Okay, so you have to told that the function of the brushes we have to the process is this is collect the current from the commutator, and that particular current that will be supplied to the external load circuit. External load circuit means external the armature of the machine that will be being whatever the armature that will be connected with the machine. Okay, to the external load circuit via the commutator and the brushes. Okay, so if we will see the construction of the brushes is the brushes are according to the constructional principle is concerned, the brushes are the rectangular in the shape. Okay, so we have a brief discussions on the what will be the construction of the brushes is whenever we have a discussion in the latter part. Okay, so these are the different essential part we have to concern. One is a field system, armature, commutator, brushes, balls and bearings, and the shaft. Okay, so these are the in the brush sections we have a two different. So there must have some simple brushes will be there and some brush holders will be there. Okay, so we have a discussions on the brush and the brush holders also, right? So these are the things we have to discussions in the next lecture. That means tomorrow I have an class from the same timing in the 10:40. Okay, so I have discussed there the remaining thing, what will be the part, what will be the working principle. That means these are that means the principle of operation. So in this principle of operation we have a discussions of the different types of coil. Okay, so according to the constructional of coils is the coils will be divided into the two different segments. Okay, पता है किसी को पता है टाइप्स
सर
ऑफ
रिपीट सर, क्वेश्चन नहीं सुना सर.
टाइप्स ऑफ कॉइल कितना तरह का रहता है
दो सर, लेफ्ट वाइंडिंग और वेव वाइंडिंग सर.
लैप
या फिर
वाइंडिंग
शॉर्ट फिश कॉइल या
यस यस
और वेव वाइंडिंग.
yes lap winding and the wave winding lap and wave. Okay, so if we will considering you already know these things, so that is we are not going to the brief of the particular section. Okay, so if I will considering this one, so this is actually what, it's a wave of lap.
लैब सर.
No, it's not lap, it's not lap. Lapping is like this. Is it now? Is it now?
Yes.
Actually, that means lap winding means it's been overlapping with the coils. Okay, suppose this will be the number one coil. Okay, and this will be my number two coils. Okay, so number one coils that will be overlapped with the number two coils. Okay, so that is considered according to the constructional principle will be considered. This will be considered as my lap winding, and the in case of a wave winding where so supposed to be this particular coil and this particular coil. So there must have some segment will be there. So this should be considered as my wave winding. Okay. So we have a small discussions on the in the next lecture. We have a small discussions on the coil when we have a discussions of the principle of operation of a DC machines. Okay. So there must have a lap winding and the wave winding we have discussing. Okay. So in the next lecture we are discussing on this particular part. Okay. So I think I will end the session for today. We will discuss more thing in tomorrow's lecture. Tomorrow in the same timing in 10:40. Okay, I am present and you will attend the session. Okay, is it clear?
Sir, I have a doubt, sir.
Yes. Tell me. Tell me.
Sir, in a small DC machine, sir, the field winding is provided with a permanent magnet. But, sir, in large scale of DC machine, is
Hmm.
there any permanent magnet provide?
In a large scale machines.
Yes, sir.
देखो the thing is that in each and every machines uh, there must have some error, right? Whenever we have an operating the machine, there must have some error. Okay, so error either it should be 5% or the error should be 6%. Okay, so depending upon what kind of magnet you are choosing. Okay, so if in case of a large size electrical machine, if you are choosing the permanent magnet, so there must have some error in the operation that will be taken into consideration, as because the large size of electrical machines having a greater number of a greater amount of voltage, and according to the output range is concerned. Okay, so if we are choosing the permanent magnet, so permanent magnet having some fixed range of the voltage and the current capacity, right? So if I
Yes,
choosing
sir.
the permanent magnet, so we have choosing the fixed magnet, or we are choosing the electromagnets. Okay, so normally each and every kind of machines, depending upon the constructional principle of concern, we are choosing the electromagnets for the small size also, medium size also, and the large size. You can choose the electromagnets during their operation. Okay, if you are choose the permanent magnet for the small, medium, and the large, so there must have some constraint. What are the constraint? Constraint is that you have to select the particular permanent magnet in a different voltage level and the different current level. That means voltage and the current level that should be different for the different magnetic operation. Am I clear or not?
Yes, sir. Yes,
ओके,
sir.
अगर तुमको परमानेंट मैग्नेट यूज करना है तो परमानेंट मैग्नेट को उसी तरह का बनाना है जिसका तुम्हारा तुमको तो आउटपुट चाहिए ना। ठीक है, तुमको अगर आउटपुट अगर नहीं मिलता है, जो परमानेंट मैग्नेट तुम कंस्ट्रक्ट किए हो, जो परमानेंट मैग्नेट तुम चूज कर रहे हो, ठीक है, उस परमानेंट मैग्नेट अगर हमारा मेरा जो रिक्वायर्ड आउटपुट है वो अगर नहीं दे पाता है, ठीक है, तो फिर तो वो परमानेंट मैग्नेट यूज करने के लिए जरूरत नहीं है। ठीक है, तुम उसके सिवा तुम इलेक्ट्रोमैग्नेट्स यूज करो। Right. So you are choosing the electromagnets either in the small size electrical machine, either in the medium size electrical machine, either in the large size electrical machines. Okay. So that is actually the drawbacks of to choosing the permanent magnet rather than choosing the electromagnets. Permanent magnets have some fixed features. Okay. उस फीचर्स के अलावा दूसरा कुछ आउटपुट वो नहीं दे पाएगा।
Yes, sir. At sometimes, sir, aging effects, sir, that
Yes.
also be considerable.
हाँ, considerable, yes. So depending upon the supposed to be some my output, suppose हमको ज़्यादा आउटपुट की ज़रूरत है, ज़्यादा पावर आउटपुट की ज़रूरत है, so that time उसका कैपेबिलिटी जो परमानेंट मैग्नेट तुम यूज कर रहे हो उस वो not capable to generate that particular output. So for that cases there will be the no need of use of this permanent magnet. Okay, so permanent magnet have some particular features, only the specific features. But electromagnets you can design according to your needs. Okay, you
Yes,
can
sir.
design your electromagnets according to your needs. According to your needs means, suppose you have a requirement of a 500 kilowatt, okay, in the output, so accordingly you have to design your electromagnets. But in case of a permanent magnet, suppose permanent magnets have a north pole and the south pole, okay, so there's particular features that will be fixed for the permanent magnet. Okay, you cannot changes anything on the permanent magnet. So that is actually the drawbacks of the permanent magnet rather than using the electromagnets in the any such kind of machines. Either it is the large size, either it should be the medium size, or either it should be the small size. ठीक है? Am I समझ में आ गया?
Yes, sir.
Okay. Any question? Any other question? Okay. So we will brief the section in the tomorrow, because tomorrow I am taking the two classes. That means I have a 10:40 to 11:30, from 11:30 to 12, because from 11:30 to 12:30 you have another classes of principal sir. Okay, so principal sir is actually not there, so that is why that classes I am taking. So two consecutive classes I am taking. So tomorrow I have taken the two classes from 10:40 to 12:20. Okay, so from in this particular session I am discussing very briefly what the different applications area of the different parts, what will be the operating principle of ADC machines, what will be the speed control, some power flow diagram, if the time will be concerned. Okay. Okay, so thank you. So I have to end the session for today because I have another classes. Okay, so thank you.
Thank you, sir.
You can leave the session for today.
Yes, sir.
All are requested to leave the session.